Following the previous video on the 3 exponent rules, we've got 2 more to go today. This one will be nice and quick. The first rule is for the anything to the 0 power rule. And anything to the 0 power, as long as a doesn't equal 0, and it usually won't, anything to the 0 power equals 1. So 4 to the 0 power equals 1. Negative 3 to the 0 power equals 1. Heck, even this crazy thing at the bottom, which teachers love to throw at students to get them all confused. Notice how the entire thing is to the 0 power, so 1. The only change in this is going to be this middle piece. What you'll observe in this one, I'm going to highlight the key component here. See how the 3, it looks like negative 3, but the 3 has the 0 above it. So the 3 is the only thing that's being taken to the 0 power. It's a little bit like if I wrote negative 1 times 3 to the 0. So what we get out of the 3 to the 0 part is 1, but then we have negative 1 times 1, so that's a negative 1. So be a little bit careful if you see a negative sign in front, but otherwise this is a very straightforward rule. Having said that, let's go on to the last rule, which is potentially one of the most important. A word that you're going to see a lot in these problems is simplify. Now, simplify means 2 things. Simplify means give your answer in simplest form, which suggests that there's no common bases and no negative exponents. So no common bases, no negative exponents. All right, with that said, here's what this rule tells me. If I have a base with a negative exponent, right? Base with a negative exponent. What I do is I take the base and the positive version of that exponent and I put it on the bottom of a fraction and I put a placeholder on the top. So you might hear your teachers literally talk about flipping it or switching it. That's really all you're doing. So look at this one, right? This is the exact same thing as the rule to the left. We have a base to the negative exponent. So we're going to take the positive exponent, 3 to the second, and put it underneath a number 1. Now in this one, this is the answer if we want exponential. If we want to simplify this more, 1/9. All right, we could do it with variables as well. 1 over the positive version of this exponent. There's nothing really more to do there, so done. Now there is kind of a corollary to this. That would suggest that if we have something that is negative already on the bottom, we're going to still flip it or switch it, but now we have to flip it or switch it to the opposite of what it used to be. So while these problems up here, well, highlighter is terrible, but while this problem and this problem switch the base from the top to the bottom, we're going to go ahead and switch this base from the bottom back to the top. So notice how it's 3 to the negative second. We could do all the math, right? The math is 1 over 1 over 3 to the positive second, and then we're dividing by fractions and blah, 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 blah. We could do all those things, or we could just kind of take the really nice, easy shortcut, and that is why you're watching a video like this one. So we're going to take this item, we're going to take the positive version, and we're going to put it up on top. You can imagine having a placeholder on the bottom, but on a fraction, divided by 1 doesn't mean anything, so we can just take that away. So here we go. Here is our exponential answer, or our evaluated answer. So keep an eye on 0 and negative exponents, and remember to simplify. You want no common bases and no negative exponents.